Have you ever felt like time is speeding up? Or maybe dragging on forever? One minute you're a kid without a care in the world, and the next you're worrying about bills and what to make for dinner. What is this mysterious force that rules our lives? Is time even real? Today, let's dive into one of the biggest mysteries of the universe, the nature of time. To start, let's think about how we usually see time. We imagine it as a straight line, like a river flowing from the past, through the present, and into the future. This is called the linear model of time. The past is fixed, gone forever. The future is open, full of possibilities. And the present? Well, the present is that tiny, fleeting moment we're living in right now. This idea seems super intuitive, right? It's how we organize our lives, make plans, and remember our experiences. But here's where things get weird. According to physics, this intuitive feeling might be just that, a feeling. Let's bring in the big guy, Albert Einstein. His theories of relativity completely shattered our everyday understanding of time. Einstein showed that time isn't a constant, universal clock ticking away at the same rate for everyone. Instead, time is relative. It can stretch and shrink depending on how fast you're moving and the strength of the gravity around you. This is called time dilation. Imagine you and a friend have perfectly synchronized watches. Your friend stays on Earth, while you hop on a spaceship and travel near the speed of light. When you come back, you'll find that your watch has ticked slower than your friend's. You would have aged less. This isn't science fiction. It's a proven fact. GPS satellites, for example, have to constantly adjust their clocks because time runs slightly faster for them in orbit where gravity is weaker. So the now you experience isn't the same now for someone else in a different part of the universe. Crazy, right? Einstein's work led to the concept of space-time. He proposed that space and time are not separate entities but are woven together into a single four-dimensional fabric. Massive objects like planets and stars warp this fabric, and this warping is what we experience as gravity. Think of it like placing a bowling ball on a trampoline. The fabric dips and curves. Now, if you roll a marble nearby, it will follow that curve. That's essentially how gravity works. But it's not just space that gets warped. Time does too. The stronger the gravity, the slower time flows. This leads to a mind-bending idea called the block universe theory. If past, present, and future all exist together in this four-dimensional block of space-time, then the distinction we make between them might just be an illusion. In this view, the future is just as real and fixed as the past. Everything that has happened, is happening, and will happen already exists. Our consciousness just moves through this block, experiencing it moment by moment, like a spotlight illuminating one frame of a movie at a time. This would mean free will might not be what we think it is. If the future is already written, are our choices truly our own? Physicists and philosophers are still debating this one. But if the block universe is real, why do we experience time as flowing in one direction? Why do we remember the past but not the future? This is known as the arrow of time. Most scientists point to the second law of thermodynamics to explain this. This law states that in a closed system, entropy, or disorder, always increases over time. Think about an egg. It's easy to break an egg and make a scrambled mess that's increasing entropy. But have you ever seen a scrambled egg spontaneously unscramble itself back into a perfect whole egg? Nope. That's because the universe naturally moves from states of order to states of disorder. An intact egg is a highly ordered state. A scrambled egg is a disordered state. The universe as a whole started in a very low entropy state at the Big Bang and has been becoming more disordered ever since. This forward march of entropy could be what gives time its direction. Our brains, our memories, and all biological processes rely on this increase in entropy. So we perceive time moving in the direction of increasing disorder. Now, let's jump from the vastness of the cosmos to the quantum realm, the world of the super-duper tiny. And guess what? Things get even stranger here. At the quantum level, the arrow of time seems to disappear. The fundamental equations of quantum mechanics work just as well forwards in time as they do backwards. An electron can travel from point A to point B, and the math describing its journey doesn't care if time is running forwards or backwards. So where does the arrow of time come from? Some physicists believe it's an emergent property. It doesn't exist at the fundamental level, but appears when you have a large collection of particles, like in our macroscopic world. It's like temperature. A single atom doesn't have a temperature, but a group of atoms does. Similarly, The arrow of time might only emerge when we zoom out from the quantum world to the world we experience every day. This brings us to our own perception of time. Why does time seem to fly when we're having fun but crawl when we're bored? This is the realm of psychology. Our brains don't have a single dedicated clock. Instead, our perception of time is constructed from various signals and experiences. When we're engaged in a new or exciting activity, our brain processes a ton of new information. Later, when we look back, it feels like a lot happened, so we perceive that time as being long. In contrast, during routine or boring periods, our brain is on autopilot, processing less new information. Looking back, it feels like that time was short and flew by. And what about that feeling that time speeds up as we get older? A popular theory is the proportionality theory. When you're 5 years old, 1 year is a whopping 20% of your entire life. It feels like an eternity. But when you're 50, 1 year is just 2% of your life. It's a much smaller fraction, so it feels like it passes in a flash. Our perception of time is relative to the time we've already lived. So, what is time? Is it a fundamental river flowing in one direction? A dimension woven into the fabric of space-time? An illusion created by thermodynamics and our own minds? The honest answer is we don't know for sure. It's one of the deepest and most profound questions we can ask. What we do know is that our understanding of time has evolved dramatically, from ancient sundials to Einstein's relativity and the puzzles of quantum mechanics. It's a concept that bridges physics, philosophy, and psychology. Each field gives us a different piece of the puzzle, but the complete picture is still just out of reach. But maybe the exact nature of time isn't what's most important. What matters is how we use the time we have. Whether it's a fixed block or an open river, our present moment is the only one we can truly experience and act in. It's where our choices are made, where our lives are lived. Maybe the real mystery isn't what time is, but what we choose to do with it. So the next time you feel time slipping away, take a moment. Appreciate the now, because whether it's an illusion or not, it's all we've got. What do you think? Is time real? Let me know your thoughts in the comments below. I'd love to hear your theories. Thanks for watching, and if you enjoyed this journey through space-time, don't forget to like and subscribe for more deep dives into the mysteries of our universe. See you next time.